Bismillahirrahmanirrahim. I'm Engineer Zarif Khan, and today we will discuss about the design of a 10-story building using Etabs 2016. Let me share with you first of all the drawings which we will design using Etabs. So this is a 10-story building. In the lower basement there is car parking, and in the upper basement it's another car parking. Then in the lower ground we have shops, and then on the upper ground we have shops. In the first floor we have also shops. Then in the second floor, this is the second floor, first floor shops, then second floor flats. So we have flats in the second floor. This is like this, and in the third floor up to the sixth floor we have flats but of different design and orientation. So first of all we have to think about that how to make the grid system for this plaza, as we have some walls, infill walls inside the grid lines. Also we have some projected shades, balcony. So for that we have to define first a grid system. According to the drawings, the architecture drawing, the grid system has been divided into horizontally 4 grids, and vertically it's also 4 grid system. Horizontally, the first grid is 25 feet and 4 inches, then 29 feet, then 29 feet, then 20 feet 2 inches. Vertically, the grid system is actually the vertically grid line is the left side line is in the slope. So we have to define the grid system first of all. So this is the drawings. Now we will open new window. Let me share with you the template. So we will use a setting from the model file. Actually if we use the existing setting from a model, so we can use that one. So let's use that one. So suppose we have a system of this is a 10-story plaza. So we will use the properties inside that plaza. Okay. As you know that we have number of grid lines in x direction. How we will define? We will mention the grid line numbers. So for that, if we look at the drawings, in the drawings there are horizontally as well as vertically. So the main grid line are A, B, C, D and E, and vertically we have 1, 2, 4, 5. 1, 2, 3, 4, 5. But inside the grid line we have walls, infill walls like this. These walls are inside the grid lines. So to put the loads of these walls we have to define some interior grid line as well. Similarly, if we see these plates, so for this we have to define some grid lines which we can extend from the grid line exteriorly. Like This is the balcony, which is approximately 3 feet extended from the exterior grid line. This is another balcony, and this is extended 3 feet. This is another balcony. So for this we have to add a grid line on the bottom as well as on the top, on the right as well as on the right. So for that, if suppose I define this grid line, similarly this grid line is not in uniform shape. This is in slope. So for this we have to define grid line for this separate, this for separate, this another column, another column, another column. So suppose we have to if we follow the grid lines as mentioned by architect, so we can define the grid lines as required. So for this, let me share with you. Let me just, if I put the grid lines approximately 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15. Let's say we define grid lines 15 grid lines. Later we will discuss why I put here 15. Similarly, vertically, if we go, so vertically we have 1 2 3 4 5 6 7 8 9 10 11. We have 11 grid lines. Okay, let me put that this distance, actually the grid lines are not uniform, so we will change these grid lines. It means what is 14.5 feet, and vertically let me put this 9.6 feet. Okay, now come to the bottom story height, number of story, typical story height. So this is bottom story. Bottom story mean that how much this building will be embedded in the earth, like we can say that from the initial to the bottom of the foundation. So let's assume that we will go approximately 5 feet from the natural soil level. Let me put on 5 feet. Typical story height is 11 feet, and 11 feet, this total stories we have 12 story, because one story for the bottom and one story for the top rooftop. So 12 story building. Actually the actual stories are 10, but we are putting 12 here. Okay, now let me make it okay. So this is the grid system for the plaza we are going to design. This is 10-story plaza, and now the next step is that how we will make this grid system according to our requirements. So for this, let me change the grid system. We can edit the grid system. My modify grid system. So this is the grid system. Here we have two grid line system, one for the horizontal and one for the vertical. Horizontal, here display grid system as ordinates like if we go from 0, then we will adding, this is the ordinate system, 14.5, 29, like this, uniformly adding, and then we are going to top. If we make this display grids data as spacing, H just define spacing between two grid lines. So here grid A is according to my model, to our drawings, we need here 4 feet. Then another grid line is 3.75 feet. Then another one is 3.25 feet. Other one is 3.25 feet. The other one is 3.25 feet. Then 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Then we have 11 feet 10 inches. 11.82 approximately. Then we have 14.5. Then another 14.5 feet. Okay. Then 14.5. Okay. Then 10. 1, 2, 3, 4. 1, 2, 3, 4. Then we have this 10 feet. Then we have 5 feet. Then we have 5 feet. And then we have 4 feet. So this is the horizontal grid line I changed. Actually we have to work on it. Like if I go to the drawing system, here we have this is like, if we see this system. So grid number 1A. So this is another grid line. This is the exterior one. So this is the first grid, this is the second grid, this is the third grid, fourth, fifth, okay, and the sixth one, then seventh one, eighth, 9, 10, like this. So for each wall we have to define a grid system so that we can put the loads on that grid system. Okay, if we make it okay, so now we can say like this is the horizontal grid system we changed. So now according to the grid line system, this is according to the drawings, actual drawings, so we can easily put the values on it. Similarly, we have to now put edit the grid line in the vertical directions. So this is vertical direction. The first grid line is 4 feet for the balcony. Then we have 9 feet 7 inches. 9.7 inches. Then 9.7 inches. Then we have 9 feet 3 inches. Then 9 feet 3 inches. Then we have 11 feet. Then 11 feet. Then we have 9 feet 3 inches. Then we have 9 feet 3 inches. and the last one is 4 feet for the balcony. Okay, so I make it okay, and now we see this is the picture grid line system. We make it. So the grid system is now ready. We have to save the model. Okay, I just give the name till story. Plaza at shop. Okay, so now the model is saved. Now the next step is that we have to define material properties. For material, if you go here, so already we have selected one model properties, and we have just available, we know all the material are available here. Just we have to look. Suppose if we use the concrete of 3000 psi, so just we will modify the material. Let's see here. This is material name C3. C3 means concrete 3000 KSI. We have unit weight, volume range from usually 145 to 150. Okay, so this is the modulus of elasticity. Modulus of elasticity we have to change according to the strength. For this we have formula that let me share with you the formula. Suppose if we have 3000 psi strength, so according to the formula ACI 8.5, 57,000 into square root of FC prime divided by 1000. So according to this formula, we have this one 31,22,018. So it's from here. If suppose this is 4000, so it will be changed. So this is okay. This is 3000 psi strength here. It's okay. Dynamic properties and make it okay. Time dependent properties. Okay, make it okay. Then we have to define load combination. Say load combination already available. UVC 97. Okay, this is suppose we make it 8.5. X direction. This is upon 2B. This is soil SC. Actually, the soil is giving strength approximately 1.5 ton. So already defined. Okay. Now come to the other one, this one, modify 8.5 and it's okay. Make it okay. Now we have to put the values, column values, the structural elements. So we already section defined. Let's see this frame section available. We have all these available sections here. Let me just change one. Suppose we have columns. Column is 18 by 18. So let's modify properties. So 18 by 18 column. Strength is 4000 psi, and this is the properties rebar system. Like this, we have 60 grade rectangular. So modifiers. Here we have to change this one, like 70 according to code 70. Okay, it's okay. And section properties like this. So we have area, the grass area is 3 to 4, and then the effective area, moment of inertia, then slenderness ratio, modulus of rupture, okay. These all properties already defined and available here. Okay, if anyone want to add some new property, then it's easy. Just click here, add new property, select concrete, okay, rectangular. Suppose I column of 36.36. Okay, I put the strength of 3.5 psi. Okay, this is the dimensions. Okay, now rebar system 60 psi, 60 grade steel dies. Okay, modify. This is actually the correct sections we have to take from the code 0.70. Okay, if we go here, building code of Pakistan, so correct section. Stiffness properties of reinforced concrete and masonry shall consider the effects of correct section. Okay, so we have to consider in modeling requirements. The mathematical model of the physical structure shall include all elements of the lateral force resisting system. The model shall also include the stiffness and strength of elements which are significant to the distribution of forces and shall represent the spatial distribution of the mass and stiffness of the structure. In addition, the model shall comply with the following. Stiffness properties of the reinforced concrete and masonry elements shall consider the effects of cracked section. Okay, so we see next the crack. What is the crack? One is eye grass and one eye cracked. Okay, so we have to consider eye cracked. Desired assumption. The effects of cracking on member stiffness shall be considered. The drift ratio of piers and columns shall satisfy the limits specified in chapter 16 of UBC 97. Okay. So this is the cracked formula. We can use okay. So here we use crack section. Okay, For that, let's see. C36 by 36. Okay. Okay, so this already existing. We have to make 36 by 36 cc. So till date we have aligned, and we will this is the part 1, and inshallah in next video we will put the columns, structural members, columns, beams, load, application and all. So thank you so much for watching this. Allah Hafiz.